Title: What is an elevator encoder and why does it affect ride comfort? Hook: when an elevator starts with a jerk, vibrates at low speed, stops unevenly, or relevels repeatedly near the floor, many people immediately suspect the traction machine or inverter. But in modern elevator systems, the real issue may come from a smaller and less visible component: the elevator encoder. An elevator encoder is not just a speed sensor, it is a motion feedback device that helps the controller understand what the motor and elevator car are actually doing in real time. Without stable encoder feedback, modern VVVF elevators cannot maintain smooth acceleration, stable deceleration, accurate floor stopping, or reliable low-speed control. What is an elevator encoder? An elevator encoder is usually installed on the motor shaft or traction machine. As the motor rotates, the encoder rotates with it and generates electrical pulse signals, or digital feedback signals. These signals help the elevator controller calculate several key motion details: motor speed, rotation direction, travel distance, real-time car position, deceleration timing, and floor leveling behavior. So the encoder is not only measuring rotation. It is part of the elevator's motion feedback infrastructure. The controller uses encoder signals to check whether the elevator is following the intended speed curve, travel profile, and stopping logic. This is especially important during final deceleration and floor leveling. How the encoder works at the system level. The encoder converts mechanical movement into feedback signals. First, the traction motor rotates. Because the encoder is mounted on the motor shaft or traction machine, it rotates at the same time. Second, the encoder generates signals. Depending on the type of encoder, optical or magnetic sensing elements create pulse signals or digital position data. The signal frequency changes with motor speed. Third, the controller processes the feedback. It reads pulse count, pulse frequency, and signal phase relationship to understand the elevator's movement. Fourth, the controller and inverter adjust motor output. This is called closed-loop motion control. The elevator does not simply send power to the motor and hope the movement is correct. Instead, the system continuously compares target movement with actual movement. If the actual speed is different from the target curve, the controller corrects the motor output in real time. That is how modern elevators maintain stable acceleration, smooth deceleration, reduced vibration, and accurate leveling. Why encoder accuracy affects ride comfort. Elevator passengers are very sensitive to irregular motion. Even small changes during startup, deceleration, or final stopping can be noticeable. If encoder feedback is unstable, the elevator may begin making repeated corrections near floor stops. Passengers may feel this as jerky startup, uneven deceleration, low speed vibration, slight bouncing during leveling, delayed door opening, or repeated leveling after the doors open. In some cases, the elevator may run normally at full speed, but become unstable during low-speed operation near the floor. That is because final leveling requires very accurate feedback. So when ride quality problems appear, the traction machine is not always the cause. The feedback system should also be checked by qualified elevator technicians. Encoder role in VVVF and PM motor systems. Encoders are especially important in modern VVVF elevator systems. The inverter depends on feedback to regulate motor speed and movement behavior. In permanent magnet synchronous motor systems, encoder accuracy becomes even more important. PM motors need precise rotor position synchronization. If the encoder feedback becomes unstable, the system may experience torque fluctuation, increased current, low speed instability, reduced efficiency, and repeated leveling correction. This is why encoder installation quality is so important during commissioning. Small issues such as coupling tolerance, grounding noise, shaft vibration, cable routing problems, or signal interference can affect the whole motion control loop. Common encoder types. There are several types of elevator encoders. Incremental encoders generate pulse signals based on movement. They are commonly used in standard traction elevators and speed feedback systems. Absolute encoders maintain unique position data. Even after power loss, they are often preferred in high-rise elevators, PM motor systems, and advanced leveling control. Optical encoders can provide high resolution and positioning precision. magnetic encoders are often more resistant to dust, vibration, and contamination, which can be useful in industrial or harsh environments. Rotary encoders measure motor rotation and are widely used in traction systems. Linear encoders directly measure displacement and are used in more specialized positioning applications. The right encoder depends on the elevator system, control strategy, building requirements, and maintenance conditions. Common encoder problems. Encoder-related problems often appear during installation, commissioning, or modernization. Common causes include shaft misalignment, loose coupling, grounding problems, shielding failure, inverter interference, shaft vibration, moisture inside connectors, or signal instability. These problems are sometimes misdiagnosed as motor or drive failures. That is why troubleshooting should be done carefully by qualified elevator technicians. The goal is not simply to replace the encoder. The goal is to confirm feedback stability, controller compatibility, inverter compatibility, installation quality, and long-term maintenance accessibility. Conclusion: an elevator encoder is far more than a simple speed sensor. It provides real-time motion feedback for the traction control system. It helps the controller manage motor speed, travel distance, car position, deceleration timing, floor leveling, and PM motor synchronization. In modern elevators, ride comfort depends not only on the traction machine, it also depends on the quality of the feedback loop. For more details, you can read the full article here. https://elevator encoder, how it works.